حكينا أنه باللينير ريجن بيكون الفانكشن هو K prime W by L into VOV times VDS minus half VDS squared. وحكينا أنه بالساتوريشن ريجن بيكون ال ID هو half K prime W by L or half K into VOV square. Okay. ورجعنا قلنا لل PMOS device you either take absolute value of VGS, VDS and VT يعني كلنا بناخذهم ال absolute quantities or and use the same equations. Okay. or قلنا فينا ناخذ ال VSG, VSD and absolute value of VTP. اوكي لأن الكونديشن هون هي بالأنموس إنه VGS أكبر من VTN هون sorry less than in the cut-off region بيكون off and then for it to be on we need VGS greater than VTN and for it to be on we need VGS greater than VTN. What determines the linear والsat هون ال VDS is small, it's less than VOV and here VDS is large and greater than VOV. Okay. هلا we will take now an example of a PMOS device, and in this example we have the PMOS device is being biased at the gate by 2 resistors. So this is the PMOS device. عطول محل الارrow عند node S, and in the PMOS we see in the arrow is inward and the source is the higher voltage and this is the gate. And then my transistor is biased by 2 resistors R1 and R2 موصولين بالجي بين ال VDD plus 5 volts home and the ground, and also the source is connected to VDD plus 5 volts, and then I have a small resistance R3 موصول على the drain. In this example we have given VTP is equal to minus 1 volts, KP اللي هي K prime W by L يعني is equal to 1 milliamp per volt square, and they are asking us to design for saturation region operation يعني بدي حدد resistor values so that the device is biased in the saturation region with the following characteristics, with the ID equal to 0.5 milliamps and VD equal to plus 3 volts. هيدا الجيفن اللي عاطينا إياه, and they are asking me to find R3, R1 and R2 values. The first thing that we need to understand is that since I have a PMOS, the current is going to flow still from the high voltage to the low voltage. حيمشي مثل ال arrow direction يعني حينزل من السورس للدرين. So the current, the positive current is going to flow from the source to the drain. The same current that flows into the source is the same current that is going to flow out of the drain. Okay, so this means what is IR3? What is the current that is flowing in resistor R3?
0.5 milliamps.
Exactly, so it is equal to ID is equal to 0.5 milliamps. Great. Now I also know that VD is equal to 3 volts. From these two quantities, this is equal to also VR3. This implies that R3 is equal to VR3 على IR3. This is equal to 3 over 0.5 milli. So this is equal to 6 kilowatts. Okay. So we can find now R3. Okay. حدا عنده سؤال? It should be clear, right? Okay. So the next thing that we want to design for is we want to design for R1 and R2. Let us inspect the circuit little bit. To find R1 and R2, I need to solve something on the gate side, right? And let us inspect how the currents are flowing at this node. We know that the current that is flowing into the gate is how much? 0.
0.
No current flows into the gate. يعني any current that is going to flow in R1, okay, IR1 is going to be equal to 0 plus IR2. Okay, so therefore, in this scenario, because I'm connected to the gate of the transistor, IR1 is equal to IR2. Okay, now, whenever, anytime that I have two resistors where the same current is flowing in them, إذا أنا عندي هون plus 5 volts, I have R1, sorry for the noise from outside, this is R2, and this is the ground. Nothing is flowing here, the same current is flowing here. Can I use voltage division to determine the G node? What's the voltage at node G? شو voltage at this node if G is sitting between two resistors R1 and R2 and the same current is flowing in those two branches?
R2 على R1 plus R2 times 5.
Yes, correctly. So if I have this is really a voltage divider circuit لأنه نفس الكرنت قاطع، لأنه أنا فيني أقول إنه 5 volts is equal to I times R1 plus R2, right? And VG is equal to I into R2. Therefore, VG is equal to R2 على R1 plus R2 times 5. You should have seen a voltage divider circuit from before. Okay, so therefore, because the transistor current is 0, I can assume this relation, and this relation holds because IG is equal to 0. يعني currently رايح هيك equal to 0. Great. فإذا now if I go to this picture, if I want to find R1 and R2, or at least the ratio between them, the first thing I need to think about is I need to find what's the value of VG. Okay, now I know that the transistor is in what region? The transistor is in the saturation region. I have ID, I have VTP, I have K. I can solve for VOV and I can solve for VSG. So because the transistor is in the saturation region, okay, so transistor is in sat. Therefore, this is the assumption that they are telling me half Kp into VSG minus magnitude of VTP all squared. Great, but I know that this is 0.5 milliamps. I know that this is 1 milliamp. And this is VSG, I'm trying to solve for it, and VTP in absolute value is 1. Okay, so half and half are going to cancel from both sides. يعني this and this will cancel out. Okay, لأنه half milli, I will cancel them. And then I will end up with VSG minus 1 is equal to 1, all squared equal to 1, which means that VSG minus 1 is plus or minus 1. So this means that VSG is plus or minus 1 plus 1, which means it is equal to either 2 or 0. Which one do I pick? Which one do I pick now? The 0 or the 2? If I pick the 0, would the transistor be on? The VSG is a positive quantity. VSG should be positive. So I should pick a 0 will make the device off. So I'm not going to adopt this. Therefore, I have to pick this because I'm going to set that VSG is equal to 2, which is greater than VTP, an absolute value. Okay? Now that we know which solution we picked, we can do a check. Okay? So this is VSG. Just to do a check, as a sanity check, we have VSG minus magnitude of VTP. This was equal to 2 minus 1, which is equal to 1. And VSD is equal to VS كانت 5 volts. هذا بس as an extra practice for you. And VD is 3 from the given. Okay, so VS 5 or VD is 3. يعني VSD is equal to 5 minus 3 is equal to 2. So therefore I am in the saturation region. هيدا check هيك extra check. نحن عم نتأكد إنه all our calculations are correct. Now, my objective or my goal is to find VG. So now if VSG is equal to 2, this means that Vs minus Vg is 5 minus Vg is equal to 2. Therefore, Vg is equal to 5 minus 2 equals to 3 volts. Okay? Now that I found what Vg is, I can use the relation here to determine the ratio of R1 and R2. Okay? So, we are going now to go back to equation star. Okay, so we plug in star from equation star. We have Vg, which is equal to 3 volts, is equal to R2 over R1 plus R2 times 5 volts. Great. I have one equation. How many unknowns do I have? I have 2 unknowns here, right? So typically only in this type of problem where we are looking at the 2 resistors that create a voltage divider, because we have 2 unknowns, we are going to assume, for example, R2 equal to 3. This gives me that I can solve for R1 equal to 2. And here we are going to use mega ohms, okay? And the reason that we are going to use mega ohms is because we want low power, okay, for low power operation. Let me ask you this question. So here we did 2 things. First, we determined the relation between VG and the VDD. Then we found what VG is. Okay, so first we determined the relation. Okay, then we found what Vg is. And then from this relation, we resolved the 2 equations, 2 unknowns, by taking an assumption that R2 is 3 and R1 accordingly can be found to be 2 ohm, لأنه 3 على 3 plus 2 على 5 ضرب 5 بتعطينا 3 يعني. Okay, now what do we mean here by low power operation? إذا الريزستور بالميجا شو بيصير الكورنت؟ I have here 2 resistors that are 2 mega and 3 mega. And I have plus 5 volts. Yes, yes, Ali. Or who was asking? Yeah.
The current will be approximately to 0.
يعني بالمايكرو right 5 على 5 ميجا حيطلع عندي 1 مايكرو amp. So نحن because here I am not using this current to operate anything, I'm just using it as a voltage divider. I want to benefit from the fact that the current is very small to create the specific voltage that I want to operate at. يعني منه comparable للملي amp drone. What is the power? يلا هيدا practice question for you. What is the power of the resulting circuit? يعني أنا عندي هلأ صار السيركت هيك شكله. عندي هون بعد برانش فيه الترانزستور. Okay, so this is 1 micron that is flowing in R1 and R2. And then I have the transistor. Okay, and the transistor عنده resistor هون وعنده plus 5 volts وعم يمرق لي ID. What is the total power of the circuit? What is the total power of the design?
5 volts times ID.
5 times ID plus 5 times IR1, right? مش هيدي current يعني this is very small, so this is 5 times 0.5 milli plus 1 micro, which is negligible. Okay? Okay, great.
squared over R.
Yes, Waad, can you repeat, please?
كده نعملها V squared over R.
Yes, بس كيف بدنا ناخد R بالترانزستور؟
اوكي.
Okay, so أفضلنا يعني بتصير إنه we need to know what the supply is providing what current, right? So and the supply providing هالقد plus هالقد, right? So I1 plus I2, okay? Not only يعني power not only dissipated in the resistors, okay? طيب great. So this was our example. Anybody has any more questions? Okay, great. طيب هلا حنحكي عن شيء اسمه channel length modulation, and this is important for us because the channel length modulation is a property that we will need when we do the small signal analysis for amplifier circuits. Great. What the scientists discovered is that because the channel is not linear, and we will explain this in other courses, what happens is, although I have a certain channel length L, okay, when VDS becomes very large, L is going to drop, and therefore L for the channel is going to change. And so they changed the equations, and they said I can model my equation in the saturation region, okay, as follows. ID is equal to half K prime W by L. هيدي نعرفها نحن VGS minus VT all squared زائد a factor that is linearly changing with VD, okay, يلي هو عندي constant اسمه lambda times VDS. يعني نحن بنعرف هيدا الفاكتور اللي هو 1 حطوا لنا component يلي هو linear as function of VDS, and the parameter lambda is what we refer to as the channel هو constant يعني length modulation parameter, and the unit for lambda is V inverse. ليش V inverse؟ لأنه أنا عم بضربها بفولتج، so بدي هيدا بيطلع عندي constant. أوكي، هيدا اليونت لإله current أمبير، وهيدا البارت بيطلع a constant that is unitless. Okay, now this formula has many faces, but first let us look what does this mean. If we go back to the current curves, okay, what this means is that instead of the current being constant, here the current is going to be somehow slightly linearly increasing, very small. لأنه هلا بنشوف اللامدا هي كتير صغيرة، constant كتير صغير. The scientists discovered that really if I take those lines all the way back، وهيدي فينا نشوفها إنه إذا أنا بدي أقول إن ال current is equal to zero، إذا بحط الإيكويشن ال current equal to zero in saturation, they are going to intersect at some voltage whose value is equal to minus VA volts. هلا بنشوف بس what does this VA volt mean for me. نحن اللي بهمنا فعليا إنه أنتم تعرفوا إنه هون منه perfect constant، عنده شوي slope. Okay, and this little slope is really modeled by this lambda that was inserted here in the equation. طب okay, I can also write this equation in another form. Okay, I can say that, let me define that 1 over lambda is equal to VA, this voltage that we talked about, which is called the early voltage. And in this scenario, I can rewrite my current ID as half K prime W by L times VGS minus VT all squared into 1 plus ما هي 1 على lambda. I'm going to say VDS على VA. Okay. هلا, although the current does not operate in the far negative region اللي شفناه, بس إذا بدي أحط hypothetical equation, hypothetically, although it does not exist, okay, ID is going to be equal to 0 لما VDS is equal to minus VA. ID is going to be equal to 0 when VDS is equal to minus VA, and this is independent of what VGS I'm operating at. وهيدا هو ال early voltage اللي حكينا عنه بالصورة هون، إنه هيدول كلهم عندهم إذا بنرجع على الانترسكشن مع الإكس أكسس بيلتقوا على نقطة واحدة. هلا we're not going to worry about proving this. What we want to look into from now on, إنه when we say included channel length modulation, we understand that there's a lambda factor here, or that there is a VA factor here that is included in this model. Okay? So, what's the third thing that we need to know about this? The third thing that we need to know about this is that VA is equal to VA prime times L, and this parameter VA prime is constant for a given technology, and it does not vary with L. بينما إذا جينا قلنا transistor T1 عنده L1 equal, let us say 1 micrometer, and the transistor T2 عنده L2 2 micrometer, then VA1 حتكون VA prime ضرب 1 micron, and VA2 حتكون VA prime ضرب 2 micron. So هيدي بس logistics of how this might change with the channel length of the transistor. يعني حسب أنا geometrically كيف عملت له design نعطيكم ال constant and you scale it by the given L value. وال1 على lambda هي VA. So فينا نطلع one of them. Typically we use lambda and we focus on it. Okay, so this is what we mean by the channel length modulation. Okay, حدا عنده سؤال على channel length modulation? Okay, why do we care about this in our course? The reason that we care about this in our course is that we are going now to define a new variable, okay, called little RO, okay? And this little RO can be critical for the model in the small signal analysis for amplification. ليش؟ لأنه أنا because of lambda, okay, now I have a slope in the saturation region, and the slope, يعني del ID by del VDS, is really going to be equal to شو هو السلوب إذا بدي أخذ الديريفاتيف هون؟ sorry. What is the slope? If I take del ID from this equation by del VDS شو بيطلع؟
لامدا؟
إيه ضرب شو؟ هيدي كلها constant بالنسبة لإلي صح؟ This is all a constant, right? This is all a constant times lambda, right? So in this case, the slope that I would get is going to be lambda, or 1 over VA times half K prime W by L times VOV square. So بلشنا نطلع slope. هلا حنشوف resistance شو بيكون. The resistance 1 over the slope, we refer to it as RO, is called RO. Sorry, it's sensitive. No, I don't know. 1 over the slope is RO, and therefore RO هو فعليا VA على half K prime W by L times VOV square. يعني أنا if I know the current without a channel length modulation, and I know the early voltage, I can know this little RO, and this little RO we refer to it as the MOSFET output resistance. يعني كيف الدايود كان عنده little RD، هيدا الموسفيت هلا في عنده little RO, and we will get other parameters that help us to calculate the gain, and it's specific to the saturation region. Okay, so it is specific to the saturation region. فإذا من ال VA بقدر طلع ال RO, and I also know that there is a slope for the current in the saturation region. Okay, حدا عنده سؤال about this? How to calculate little RO? يعني this is an important information or equation for us. Okay, and the other important equation is this, and of course the new current equation. Let me try this. I'll fix it later. Okay, so now we know all the equations in all the regions. So we are going to discuss the transistor itself, how do we use it, and how it functions within a circuit as a switch or as an amplifier, and as an amplifier. طيب نحن كلنا بنعرف إنه the transistors that exist in today's chips, we use them either for logical operation, and when we talk about logical operation, this means that I want the transistor to act as a digital 1 or 0. Okay, so I want the switch to be on or off. Okay, or we use them to amplify signals, and when I want to use it for amplification in analog domains, then I will operate it in a different region. So the bias point and the signal that we send to the transistor matters. What we are going to see here now is we are going to see a circuit that, depending on what region we operate it in, okay, the circuit can act either to perform as a logical switch or inverter, or to perform as an amplifier. So I have here a transistor, okay, and the transistor is connected at its gate to an input signal Vn, okay, and at its drain it is connected to a resistor R, okay, and the resistor R is connected to VDD, and here at the drain we are collecting an output voltage VO. Okay, so if I want to look in terms of the characteristics of the transistor, this is really VO is equal to VDS, and Vn in this scenario is equal to VGS. Okay, لأن هيدي الجيت وهيدي السورس والجيت, and this is the drain node here. Okay, so the MOSFET has specific parameters. Okay, so the MOSFET has parameters عنده VT وعنده a certain K, and we already know now that VGS is equal to Vn, and this is from the circuit. Okay, and we know that VDS is equal to V. Okay, and our objective is to draw the voltage transfer characteristics of this circuit. What is voltage transfer characteristic? If you recall from before, نحن كنا نرسم VO versus Vn، وإذا أنا جيت رسمت something like this, what would be this؟ شو كانت هالcharacteristics لشو كنا ندرسها؟ ل amplifier. كنا نعمل biasing ونقول إذا أعطينا signal هون okay I'm going to get a bigger signal here okay and this would be I am amplifying based on some slope information. I can know the gain. It is del VO by del VN, right, at the bias point Q, right? So هيدي الفولتج transfer characteristics بدنا نتذكر recall إنه from first lectures إنه نحن درسنا الفولتج transfer characteristics VO versus VN for the amplifier. Okay. هلا what we are going to see so هيدا is a side box how this circuit is going to provide me such a voltage transfer characteristic curve. Okay. So خلينا نطلع على ال VO versus VN. So if I want to draw now for our circuit, okay, when VN إذا بدي أجي أرسم VO versus VN هنصير نزيد على رسمي هون هيدا VN وهيدا VO. أول شي حأخده إنه حأشوف إذا VN كان أصغر من VTN. So the first region I'm going to study if VN is less than VTN. إذا VN is less than VTN أنا عندي الترانزستور صح؟ عنده here plus minus VN. Okay. So what would this tell me about this circuit? شو حأعرف عن هالسيركت إذا VN أقل من VTN؟ يعني VGS أقل من VTN. Is the transistor on or
No.
off?
It's off.
Off. يعني ID is 0. طبعا if I tell you that ID that is flowing here is 0 يعني هو تقريبا فعليا أنا كأن عندي switch is off, right? So ID is equal to 0. What is the voltage at this node D? What is V out? V out equal to VDS. What is it equal to in this case? أنا بعرف إنه هون عندي VDD وعندي هون R. If I know R and I know that ID equal to 0, what is VDD? What is V out? Sorry.
VDD.
VDD. So V out is equal to VDD minus R times ID يلي هي VDD minus 0 يلي هي VDD. فإذا أنا already I determined that, and here we don't need to. I determined that if Vn is below Vtn, my output is going to be equal to VDD. Okay? بلش يكون عالي الفولتج. Okay? Great. هلا the second region that I am going to look at is the region when Vn is equal to Vtn plus epsilon. يعني أول ما بلشت أكبر عن يعني بلشت أكبر عم يزيد الفولتج لإلي. So this means that VOV VGS أكبر من VT صح؟ And VOV is equal to what? VOV is equal to VGS minus VT اللي هو VN minus VT اللي هي epsilon, something that is very small. Okay. And logically speaking, if we look at this circuit, إذا ال VN صغيرة إذا الدلتا لل VN is very small, would my current be very large? No, so I am not going to have a significant drop across the voltage R. I'm not going to have a significant drop across the voltage R. Okay, so because VOV is very small, okay, because VOV is epsilon, okay, and the current, I expect the current to be small, okay, and the output barely has dropped. هلا هي بدها proving, so هلا we're just saying it as a story. Barely would drop. Okay, this means that, okay, VDS will drop little bit and it will be approximately little bit below VDD. يعني الاوتبوت شيء على الانبوت ودار على low current، حنكون شدينا الاوتبوت شيء بسيط، يعني very little delta across the resistor. إذا الI فرقت نتفة عن الزيرو. Okay, so in this scenario, this implies that IM, which is greater than epsilon, this implies that I will be operating in the saturation region. Okay, so typically نحن حتى تكونوا مرتاحين بالفكرة، إذا بنطلع على transistor which is NMOS or PMOS, and if we are applying here a small input, okay, the output would still typically be large. Okay, and in this scenario, the transistor is going to be in saturation. The larger for this type of circuit the input is, I will pull more current and therefore the output will be very small. Okay, هلا if we agree that when the input is epsilon and output بعده high and therefore I am in the saturation region, therefore in this scenario we can say that ID is equal to half K prime W by L, or K ضرب Vn minus Vt all squared. And can I find if I have what ID is what the V output is? شو هو ال V out بكل الحالات؟ كيف بطلع ال V out؟ VDD minus R times ID. Okay, so in all conditions, V out is going to be equal to VDD minus R times ID, and in this case, it is equal to VDD minus R مضروب بالhalf K ضرب VOV ضرب Vn minus Vt all square. فإذا in this region, this is what the output voltage is equal to, and this extends هلا بنقول امتى بيطلع من saturation to the rest of the region. Okay, in this case V out is equal to VDT. طيب great. So we are seeing that the output is starting to drop and its drop is proportional to Vn minus Vt square. Okay, will this be in saturation forever? No, لأنه شو عم بيصير عندي بالoutput هون هلا؟ الoutput now is going down. Okay, and eventually it's going to reach a certain point where the output is small enough. هيدي البوينت حنسميها B وهيدي البوينت هي A, where the output is small enough such that it really reaches the edge of saturation. Okay, so على هيدي النقطة حيكون عندي الانبوت هو VIB. Okay, والاوتبوت هو شو؟ هو VOB. Okay, so let us think of it logically. This is a little bit complex, I know, but let us try to make it a little bit clearer. So the output will continue to drop until the device reaches edge of set. Okay, يعني أنا إذا عندي الترانزستور مع ريزستور وصار يكبر الانبوت، okay، وبلش يصغر الاوتبوت، I'm going to reach the edge of saturation. كل ما ال VGS عم تعلى مع ال VN وال VDS عم تنزل لأنه عم شد أنزول، I will reach the edge of saturation. At edge of set هيدي بنسميها EOS. At edge of set إذا if Vn equal to VIB هي point B، شو بيكون ال V out؟ شو بيكون ال V out على ال edge of set؟ شو بيكون ال VDS؟ VDS حيكون بيساوي VGS minus VT right؟ but شو هي ال VGS هون؟ يلي هي VN minus VT يعني VIB minus VT so VDS is equal to VO يعني VO equals to VDS okay if and only if VOB هي VIB minus VT is this clear؟ يعني جينا قلنا أنا بدي فتش ولاقي شو هي ال edge of set point قلنا على edge of set إذا الانبوت هو VIB at edge of set VDS بيكون بيساوي VGS minus VT therefore VDS هي VIB minus VT يعني VOB هي VIB minus VT. Now can I solve for this if I tell you that we already know VO as function of VN in this region? يعني can I use the equation star along with this equation double star to solve for use star and double star to solve for VIB because we know that يعني double star بتعطينا what does double star tell me? Double star tells me that VO is equal to VDD minus R times ID اللي هي half K prime times VGS minus VT. Okay, I'm going to plug in this equation VOB. Okay, so هون ححط VOB. Okay, وهون ححط محل ال VGS VIB. Okay, so we're going to plug this here. Okay, half RK VDD. Okay, and I know that VOB is equal to what? From double star, sorry, this is the single star. From double star, what do I know now? VOB here, VIB minus VT. Okay, and I can now have one equation, one unknown. Sorry, I'm done this. Okay, so this is one equation, one unknown. Now we can solve for VIB, for point B. Okay, فإذا نحن اللي حكيناه هون إنه أنا at point at point B إذا ال VN هو VNB ال V out حيكون VIB minus VT and then we said let me go back and use the equation of the current being in saturation which relates VO to VN اللي طلعناها and we plugged in VOB, we plugged in VIB and we solve for what the value is going to be equal to. Okay, so we can solve for VIB from this equation. حدا عنده سؤال على هيدي equation? Anybody has a question? Yes, Fuad.
Doctor, can you go to the previous page?
Yes, sure. Up on
Can you repeat the part of 2, the beginning of part of 2?
بأول part 2 جينا قلنا if we look at the transistor the overdrive voltage okay the overdrive voltage is small لأنه I am just getting out of VTN يعني بعدني شي عم بطلع من ال VTN okay so I have a small overdrive voltage and typically if the transistor has a small overdrive voltage the current drive will be small so ID here I in the beginning, if I am epsilon, the current is going to be small that is flowing here. So the voltage drop across the resistor will be small. إذا عندي small voltage drop يعني الترانزستور بعده ضعيف عم بشد شوي رح انزل شوي عن ال VDD. So كنا عم نحكي نحن in the vicinity of this point here for example. Okay? And because I'm going to drop little bit away from VDD, this means that my VDS or Vout is large, okay? And this means that my VN or VOV is small, لأن VOV هي epsilon, and this gives me a good guess that I am in the saturation region. هلا, we cannot prove this only by words, but we are going to give you a rule of thumb that typically, if I am operating in this form of a circuit or for any transistor, if the input signal is small, the overdrive voltage across the input signal is small, and if the output voltage is large, then عندي هالimbalance بين هالtriangle وهالtriangle فيني roughly speaking اعتبر انه ال VDS as a rule of thumb اكبر من V of V وفيني اعتبر انه ال device is in the saturation region. هلا اذا بنجي بنطلع على هيدا السيركت كيف عم بيشتغل، عم ببلش off، عم ببلش ال output high، the output is maintaining its high state and dropping until the input becomes very large, okay? And when the input becomes large, the output is going to drop and become small. يعني نحن عم نبلش بهيدا الريجن، إذا بدنا نجي نرسمها هيك كليتل sketch. In this region, the output is high and the input is small, okay? Whereas in this region, إذا بدي أطلع عليه ولا السيركت كسيركت, the output became small and the input صار بالhigh range, okay? So my input is large, okay? So this is really what is happening. لما الانبوت يكون large مين عم يكبر معه للانبوت؟ وين ال VGS عنا هون؟ If the input is large, let me delete it from here and explain on it. Okay, so if the input is large, okay, and the output is small, when ال VGS يعني صار عندي big overdrive بالنسبة لل VT، صح؟ أنا صرت هون صار عندي big delta بالنسبة لل VT. Okay, so the transistor as a whole is becoming stronger and it is capable now of pulling the output down. Don't be confused with what we learned that the current بيعلى مع ال VGS. ما تضيعي فيها هاي. هو مزبوط هو الكرنت بيعلى مع ال VGS. اوكي، بس مش ان يعني مش انه بالساتوريشن هو اعلى، ما انا عم كبر ال VGS. يعني اذا بدنا نرجع على هيدا الكاركترستيك كيرف اللي رسمناه بالاول، اوكي، if we want to look at the characteristic curve هلا برسم لكم اياها. I am really jumping in my gate voltage by taking the gate voltage up. اوكي، يعني الجيت voltage عم يعلى فأنا I am moving in an opposite fashion. هلا I will draw it for you. But my first question to you وعد, is it clear بس هيدا ال big triangle small triangle concept in your head now?
Yes. No, it's
إذا
clear.
عندي الكاركترستيك كيرف نازل نزول، لما الانبوت هو كتير كبير الاوتبوت حيكون صغير، والاوتبوت صغير حكون انا مجبوره اكون باللينير ريج. اوكي، so طيب what if my input becomes now very large and really reaches VDD? Okay, so in the third category or in the third thing that we are going to ask ourselves, what if my input is now VDD? بأي region أنا حكون هلا؟ يعني أنا إذا عندي هون VDD وهون the output is going now to be pulled even more down. Okay, وهيدي حنسميها point C. Okay, so شو بصير عنا هون إذا هيدي كتير كبيرة وهيدي كتير صغيرة؟ بأي region بصير أنا هلا؟ إذا VDS is very small.
Saturation region.
Exactly. Okay. لا VDS صغرت كتير، لما تصير صغيرة ال VDS بروح على
linear.
linear.
نفس الشيء إنه الانبوت كبير والاوتبوت
صح.
صغير، أو حيكونوا both linear ما هيك؟
True. So the transistor will be linear when the input is large and the output is small. In this region, it is going to be linear. In the previous region, we were in set. I'm going to repeat this in a more brief fashion next time, and I will show you إذا رسمنا اللود لاين للريزستور على current characteristics كيف عم ننقل من region لريجن.